I'm very pleased to be here to speak about such interesting topic. And I hope to be able to collaborate a little with knowledge and certainly learn a great deal from you. I thank the World Cup Leaders Forum for providing me with the opportunity for this valuable experience. This is my first time here in Korea, and I'm very happy to be here and know such interesting and very nice people and a beautiful place. Thank you so much. This forum selected important issues to be discussed, offering a great opportunity for consumer and producer to develop together a more sustainable model. For producing countries, abnormal climate causes real impacts on both productivity and quality. Solutions that will be discussed, and I'd like to present the effort of research by Brazilians to face climatic change and their impact on coffee quality. The coffee producers, or the coffee producer, has important challenges facing climatic change, ensure yield, and avoiding loss of coffee quality. As climatic change can result in new physiological crop conditions and new sanitary conditions of plants, fruit, and seeds. The most relevant effect of climatic change comes from the variation of temperature, excessive rainfall, and long droughts. Those effects might affect coffee production and its quality. It's better. Thank you so much. So here we can observe some pictures that can represent these effects. This picture, some of you visit Brazil in this year, and we almost be scared with this situation considering the excessive rainfall. Of course, it will affect the coffee quality. To overcome new climatic conditions, the following are necessary: new studies in coffee breeding, new technologies for harvesting, processing, and storage, and new technologies to ensure yield. Considering these points, I'd like to emphasize or to give an example considering the Brazilian experience. So let's see the Brazilian case in the last decade. Although coffee production in Brazil has increased in the last decade, no deforestation was observed to plant new coffee areas. In the last 15 years, the coffee yield in Brazil increased from 8 bags per hectare to 25 bags per hectare. It's unique in the world. Considering this point of view and others variables, nowadays Brazil could be considered as one of the most sustainable coffee producers in the world. Although production is an important issue, today I will focus principally on the change in coffee quality. To understand the effect of climatic change on coffee quality, we have to analyze the production of commodity, represented here, and specialty coffees separately. We have to analyze these two kinds of coffee. For commodity coffees, we need to study the effect of climatic change on the occurrence of defective beans and defective beverage on a large scale. That means we need technologies to produce clean cup, minimizing the quantities of defective beans as a solution to face the climatic change. Nevertheless, minimized effective beans might not be enough for specialty coffee production. It means we have to ask if climatic change will interfere in coffee attributes if only ripe fruit is collected under different environmental conditions. Considering those points, increasing temperature, excessive rainfall, long drought, etc., I'd like to give an example for how to face the increase in the temperature. The increase in temperature can reduce both areas suitable, very well presented before, for coffee production and coffee quality. Currently, we are developing a germplasm bank scanning project aiming to identify new potential varieties in Brazil. In a joint partnership with Agronomical Institute of Campinas, we are evaluating a germplasm bank composed by thousands of wild accessions from different parts of the world. Hundreds of wild accessions from Ethiopia, India, different countries, and some artificial hybrids, and several Brazilian commercial cultivars have been evaluated. We identified exotic flavor and aroma attributes not commonly found in Brazil or Arabica coffee. It's very important to emphasize that despite the fact that the plants were grown in low altitude and high temperature, this institute it's located in a very low altitude in Brazil and with high temperature. Despite this situation, it was possible to identify samples with scores above 85. It means very good in specialty coffee. This research will contribute to widen the genetic base of cultivar and will soon produce new coffee flavors and aroma and suitable for the new environment in the future. The association of excessive rain during harvest and high temperatures is the main cause of formation of defects, like represented here, the contact with oil. Of course, this is just an example to emphasize the problem, okay? The fermentation and mold infection may occur before harvest when the relative humidity is higher than 80%, when there is constant rain, or when the collection of fruit is too late. Abnormal rainfall might cause falling of fruits. Sour beans and black beans may occur, giving an unpleasant flavor to coffee beverage. Harvesting of overripe fruit and fruit fermentation, both on tree or on the ground, are causes of defective beans as well. So it's very important to understand that defective beans can occur before harvesting. But the question is how to avoid this problem, how to face this problem, considering the reality that we have. To avoid those defects, it's necessary to do the following. Harvest as soon as possible, avoid fruit coming into contact with the soil, transport the fruit to processing facilities immediately after harvest, dry coffee under controlled temperature conditions in less than 24 hours, and store dry coffee under safe conditions. Safe conditions, I mean, avoiding mold development or insect attack. To present an example of the interference of environment on commodity coffee quality, I'll show an interesting space and time distribution of coffee quality based on a research collected in a regional cooperatives in the south of Minas Gerais in Brazil over a span of 5 years in the last 5 crops. If you are buying coffee in Brazil, from Brazil, probably you can understand better with this example what's going on with the quality considering the variation of the environment. This database has more than 50,000 entries. This graphic shows the variation of temperature and total rainfall from 2006 to 2011 in the studied regions. So here we have the total rainfall and the annual mean temperature. Normal annual total rainfall and normal mean temperature. Normal, it means it's the normal value considering 30 years of collecting information, okay? So it's possible to observe the variation in the rainfall and the variation in the temperature. The light blue column represents the total annual rainfall, and the red line represents annual mean temperature. Next, I will show a spatial distribution of coffee quality, and I'd like to encourage you to observe the relation between climatic conditions in previous year with the subsequent year of the coffee crop. Here, it's possible, I'd like to explain first. We are studying a region composed by 22 municipalities, and this is one municipality where we collected the data. Here, it's possible to observe the spatial distribution of quality in 2007-2008 commercial crop. The scores, here we have the scores, okay? The scores from 70 to 80 represented by yellow bullets are predominant. So in this year, we are observing a distribution. All these bullets, it represent a sample georeferenced. We know exactly the origin for each sample or each data that we have in our database. The blue, pink, and red bullets represent coffee with scores above 80. Here, it means specialty coffee, fine coffee, and coffee with problems, with defective. So the orange, green, and this is a small bullet, represent problems in coffee. Yellow represents the commercial coffee, it means fine coffee, fine cup, and blue, pink, and red, specialty coffee. Okay? Observe that in 2006, the previous year, the total rainfall was quite low. And in this year, when the crop was collected or harvested, the total rainfall was increasing and the temperature decreased. In the next slides, we can see that the distribution of quality changes in response to annual climatic change. So, exactly the same municipality, exactly the same regional cooperatives with different informations. This graphic shows the variation of temperature, in 2008-2009, here, 2008-2009, the quality was better than 2007, although the total rainfall was higher than the previous year. Nevertheless, look, the temperature, the annual mean temperature was lower. Remember that we have to understand the most important thing is the combination between the total rainfall, or the relative humidity, and the temperature. In 2009-2010, quality decreased and the scores below 70 were predominant, indicating a huge occurrence of defects. The two previous years, here, were characterized by a great amount of rain and low temperatures. In 2010-2011, the scenario was again completely different. Note the high occurrence of coffee with scores above 80 and below 70 as well. However, in 2011-2012, the last crop, we observed the best quality among the 5 years of data analysis as a result of the better climatic conditions in 2010, as we can observe here and here. Okay? All these changes in coffee quality are exactly what the market focuses on. I'd like to emphasize, we are talking about real information. It's real. And when the market, when the buyers ask to Brazilian, for example, what's going on with the Brazilian quality? What will happen? You are exactly we are talking exactly about this information, this kind of quality. Okay? But what are the reasons for this change? In my opinion, the answer is variation of climatic conditions, of course, and lack of knowledge and technology. The following question is obvious. How can this problem be solved? Although it's not possible to solve the problem completely, its mitigation is possible with knowledge and technology. Nowadays, technologies are available for both small and larger producers to harvest and prevent the fruit coming into contact with soil, and to avoid the fruit's fermentation on the tree and mold occurrence. However, many producers do not have the facilities and equipment available to process a day's worth of coffee harvest in less than 24 hours. While corn, soybeans, and other grains can dry in 6 to 10 hours, it can take anywhere from 40, 60 to even 300 hours are necessary to adequately dry coffee. It's amazing. Coffee is the unique commodity or grain that use more than 40, 60, even 300 hours to be dried. This causes a significant bottleneck in the flow of coffee harvesting and processing. So nowadays, for commodity, in my opinion, in my point of view, the significant bottleneck is drying system. Collaborating to solve this problem, we are talking about commodity, okay? Collaborating to solve this problem in Brazil, we have ongoing project to develop a new intelligent, independent, and efficient system for coffee drying. This is located behind my office. This is my university, Federal University of Lavras. It's a prototype. Recent studies have shown that it's possible to dry parchment coffee from 45% of moisture content to 11% in less than 24 hours. And the floaters, the pre-dried fruit in no more than 11 hours. It's a huge impact. This new technology goes beyond reduction in drying time. With a shorter drying time, the coffee producers might finish the harvest earlier, avoiding the collection of overripe fruit and fruit with soil contact or contamination. That means the producer could reduce the production of defective beans. The first thing is reduce the reduction of defective beans. However, do those variations happen with specialty coffee too? Can climatic change affect coffee attributes if only ripe fruits was collected under different environmental conditions? This is a very good question, and this question can open a very good discussion. To answer those questions and help us to improve the understanding of space-time distribution of specialty coffee quality, we are conducting an interesting project in the south of Minas Gerais in Brazil. So the previous research or study, we collected the information in the regional cooperatives. For this study, my team, my project, my university, we are collecting this data. We collected a total of 313 georeferenced samples in a total area of 323 square kilometers. The samples were collected in 3 altitudes: above 1,200 meters, from 10 to 1,200 meters, and below 1,000 meters. 2 types of sun exposure or slope. Remember, we are in the south, okay, on the equator. 2 types of sun exposure or slope facing the sun, okay, to the north, and facing away from the sun. It's important to try to understand the indifference of environment, the combination of slope and altitude, and the final coffee quality. And 2 groups of genotypes, one composed by red fruits and the other composed by yellow fruits. So we are analyzing different genotypes. Here in yellow, we have at least 5 different varieties, all yellow fruits. Here we are analyzing different varieties, all red fruits. For example, here we have yellow bourbon, yellow catuai, yellow catucai, etc. And here we have yellow or red bourbon, red catuai, mundo novo, acaiá, so different genotypes, all red fruits and yellow fruits. And for both 2 different processing, dry method and wet method. And we collected 3 crops between 2010 to 2012, 2010-2012. Aiming to describe the coffee profile and its relationship to crop and environment, we used a correspondence analysis, a multivariate statistical analysis method. This is a very common graphic produced or that we obtain using this kind of statistical analysis. It means each point here represents one sample, and the position depends on all variables that we are studying. Okay? When we have the correspondence, it means we have one group here and other group here. And this group is separated here and here, here and here. It means this group there is a significant correspondence with this group. Okay, is it clear? How can we understand this kind of analysis? So, it was possible to establish a correspondence between altitude above 1100 meters and a score of 85 for parchment coffee for yellow fruit. Of course, this kind of research, we have a huge amount of information, and I would love to share with you in other time, because we have shorter time to explain a lot of information that we have and we are developing in Brazil. So for parchment coffee, it was possible to establish the same correlation or correspondence for red fruits. This is red fruits. It's not so clear as yellow fruits. Pay attention that yellow fruits is a very interesting coffee for specialty coffee, and for natural coffee of yellow fruit as well. However, this is what I'd like to show you. However, it was not possible to establish the correspondence for crops and snow. It means, considering 3 crops, we couldn't identify any variation in the coffee profile for specialty coffee during 3 years, despite the environmental variation. I mean, when we have extreme variation in the environment, probably it's possible to find variations in the coffee quality for a specialty coffee. But considering the result, the conditions that we have in our region, in the studied region, it was not possible to identify this. This is a very good discussion, and I'd like to talk with you later about this. To summarize, studies show that climatic change really have a significant impact on coffee quality. The effect is different according to the coffee quality category. The most relevant impact occurs when commodity coffee producers lack knowledge and technology. The use of new technology to dry coffee within 24 hours is imperative to solve or mitigate this problem. The quality of specialty coffee production is less affected by local climatic variation than commodity coffee production. And considering a global view and global warming, to meet the needs for supplying the specialty coffee markets, new varieties suitable to different environments must be developed. Thank you so much. In Portuguese, obrigado.